There's the whole other issue of like you disturb the orbit of the planets and then people will weepy and gnashing of teeth because the solar system goes unstable. But like that's a minor issue, okay?
That kind of
So
always happens to us.
Welcome to Dead Planet Society from New Scientist. We are ruining the solar system again. I'm Leah Crane.
And I'm Chelsea White. And today we want to burn something. And we do have a good reason for it for once.
Well, to be honest, we started out with the idea of lighting a planet on fire, and then we thought about how it could be scientifically useful.
Okay, fair enough. So the way you do learning by burning, scientifically speaking, is mass spectroscopy, right? Leah, you mentioned once you've actually done this in school.
Yeah, in high school.
Oh, fancy. They didn't let us play with fire at my school.
I went to a remedial high school for pyromaniacs. Nope, it was a regular chemistry class. We heated up assorted materials to extreme temperatures and then looked at their light to figure out what elements they're made of. And scientists do the same thing all the time. Even some of the Mars rovers have little lasers on them to do mass spec.
Cool. So there's this big question that we have, and frankly, one that actual astronomers have too, which is what are the outer planets made of? Those ice giants, Neptune and Uranus, we don't really know what's deep down in them, whether they have a core or not. So what if we burned up the outer bit and found out?
To help us with this noble quest, we brought back planetary scientist Paul Byrne at Washington University in St. Louis. All right then, how do we burn a planet to do spectroscopy on it?
So it depends on even what you mean by burn, right? Because there are some techniques where you combust something, but there are also some techniques where, for example, you fire a laser at something and you turn it into a plasma.
Very cool.
Right? And so we had that on one of the Mars rovers. And so the idea is that we don't need to combust, right? Because when we say burn, like we use that term colloquially to say that the sun burns hydrogen, but like it doesn't, right? To actually burn in the sort of the sense we would use it chemically, it means you're combusting, which means oxygen is playing a role in that reaction. But no, we can definitely look at the colors emitted by a material when it's very hot. We see what light it emits when it's hot, and that tells us what's in there.
Simple.
We're gonna burn a planet.
Let's do it.
Colloquially. We're gonna heat it up. And we were thinking Uranus, not for any other particular reason other than it's funny.
Well, and also we haven't destroyed a planet in a while, and Uranus is just waiting to be
like he's just waiting to be just
come on.
pounded.
Right? How do you feel about Uranus in general?
I'm a big fan of Uranus.
Yeah?
All right, so I think, okay, Uranus is probably the type of exoworld that is, or exoplanet that is most common in the in the galaxy and possibly the universe. We just don't really know anything about them. They're sometimes called ice giants, Uranus and Neptune, but we don't actually know what's inside them. There could be a large rocky planet inside them.
I want to follow up on what you just said about ice giants are the most common planets in the universe.
Certainly in the ones that we found in surveying the galaxy, yes.
Do we know why? Is it just sort of like, is there more likelihood to survive as an ice giant because you can be further away from a star?
I don't know if we have a good explanation for why. And actually, technically speaking, the most common kind of world is actually what we call a sub-Neptune. And it's weird. So basically the largest rocky world in the solar system is Earth, and the smallest non-rocky world is Neptune. And we're actually finding a whole pile of worlds that are somewhere in between. But the thing is that there are worlds like Uranus and Neptune that appear to be much more common than the Jupiter-sized or even bigger worlds. They're not that common. And we don't know why that is. And we also don't... There's a possibility, if there's a large rocky nugget inside Uranus, it's possible that over time, it actually loses some of that atmosphere and may go from being so-called sub-Neptune, which you could also call sub-Uranus, we say sub-Neptune, and it could end up being a super-Earth. Because that thing might be maybe 1.5 times the size of Earth.
So then our plan to perhaps burn Uranus and see what's inside of it could teach us a lot
for
about
science.
The whole universe. Yeah.
Yeah.
I feel like also, speaking of Neptune, we've got 2 of them. We don't really need 2 of them.
No, it's why you've got 2 kidneys, right? One is a spare.
Yeah, so we're going to burn one, but we're still going to have another. We still have a Neptune left. It's bluer, and I like it better.
Hey,
I like it better too.
Apparently it's not bluer.
What?
So this paper came out like, I don't know, a few months ago. I can't remember when, maybe because I don't know what year it is, but like either late last year or early this year. And at least according to research in the UK, the data used to make those cool pictures, because the close-up pictures, the only ones we have, right, are from the Voyager 2 spacecraft that did these flybys in the 80s.
Yeah.
And the kind of classic pictures, there's a nice, duck egg blue Uranus and the sort of nice darker royal blue or petrol blue Neptune. Apparently, they're actually probably the same color. Neptune is probably the same kind of greeny, light bluey hue as Uranus, and it just really depends on how you calibrate the data and how you make the picture.
Well, even more so, we've got two then.
Exactly. It's all the more reason to go and just destroy one of them.
Who needs one? And also, I kind of feel like if we burn the atmosphere of Uranus, we could see what's inside, and that would be really scientifically useful.
I think there's merit in us just trying to wreck the planet, yeah. I mean, I'm up for wrecking any of them, but they're one of the easier ones to do. Much, much harder to kill old dupes, so...
Yeah, exactly. So I think we should talk about how we should go about this, because my first question is, what is the atmosphere of Uranus made of, and is it something that burns?
Okay, so first off, it's worth talking about what we think the layering of this world is like, right? Because like you say atmosphere, but it gets kind of tricky because on the very most upper portion, right, this thing is mainly hydrogen and helium. That's what that outer envelope is made of.
Those are combustible.
It's combustible, right? But you need, helium isn't, but hydrogen is, right? But you need, in the presence of oxygen, right, to be able to react it. It won't ignite on it. So if you light a match in space, you can't, right?
Sure.
So, and if you threw... Well, let me put it this way. The upper part is atmosphere, and there are clouds in Uranus and Neptune, and we've seen them. And they may even be water vapor clouds in places. But as you go deeper down, you don't have what happens, say, on Venus or Earth or Mars, where you hit ground. There may be solid rock deep, deep inside, but way before you get there, the atmosphere kind of transitions into this kind of, well, we don't really know what it is. It's possible that underneath a very, very thick atmosphere where the pressures are really crazy high and the temperatures are probably high, that mix of hydrogen and helium and maybe water and ammonia and methane and a bunch of other trace stuff, there may actually be an ocean of fluid in there, like a giant ocean of ammonia and water mixed together and a bunch of other things. But you probably grade, there isn't like a line where it's clouds and then it's water. It's probably some sort of weird gradational thing. And then as you go even deeper and the pressures get higher and higher still, there is a lot of carbon in this thing, relatively speaking. And there is at least one interior model for Uranus and Neptune that carbon under really high pressure starts to turn into diamond.
I was just going to say,
Right?
does it have a diamond core?
Well, not a core, but we think what happens is the diamond when it condenses into these chunks, they are denser than the surrounding subionic fluid, and they probably settle down, they sink like giant bergs of diamond, and then they will settle down to whatever's at the base of this weird subionic ocean, which may be contacting something like rock, and there may be this kind of peripheral layer of diamond down there.
Okay, so this has just become a space heist.
Yeah.
We burn through Uranus and we come away with a bunch of iceberg diamonds.
Even one of those iceberg diamonds will devalue the diamond market so much that like we'd be paying for bread with like spoonfuls of diamonds.
That sounds awesome. I don't care about diamonds being expensive. They're shiny.
They are shiny, they're cool, and they're really, really hard. And the vast majority of them are located out in the giant planets.
Well, let's make them incredibly common.
Yeah.
Sure. Yeah. We just need to go out there. Easy. It's not easy. We need to get rid of all of that ocean and that atmosphere.
Simple.
We need to somehow tow it back and then somehow machine it.
Yeah.
I mean, we've never done any of those things, but like we won't with that attitude. So
you know what, Paul? This world needs dreamers.
It does.
So we talked about a lot of these sort of like common elements in many planets, but thinking about what we want to do these light a flame? Like, could we set Uranus on fire itself?
We'd have to ship in a bunch of oxygen, right?
Right. And so the answer is no, because there's not a lot of free oxygen that's available to make the reaction. So our goal isn't necessarily to burn it, though, right? Our goal is to get rid of that outer layer and get to them diamonds.
I mean, here's the thing. I would like to see it on fire, but if that's not going to be possible.
That's fair. It's not so one way to do it would be if we could encapsulate the entire planet in a volume bigger than it and fill that volume full of oxygen. Yes, but I'm not sure there's that much oxygen in the solar system.
Big bubble.
Yeah. And there might be if you were to sort of strip the oxygen out of minerals, but that would be, if you had that power, why not just make a giant laser and just cut it in half?
Okay, well, I wouldn't be opposed to that either. I think you know that.
Okay, I'm fine with that. But I think, yeah, we're not going to be able to easily burn it on account of the fact that we're not going to be able to easily put the entire planet of Uranus in an oxygen-filled room.
Okay, fair enough.
Fair.
But if you wanted to go and you scooped up a whole pile of that atmosphere and you brought it back and then you put it in an oxygen-filled room, yeah, it would blow, it would burn. It would pop, actually.
Oh, what do you mean?
Hydrogen doesn't really kind of burn the way like, petrol does or gasoline. It more sort of just pops. And like, yeah, the Hindenburg was beautiful. But
I don't know if that's true, but okay.
But like a lot of what we're seeing in that video of this thing is like the girders are burning and the outer skin is burning. But the actual helium or the hydrogen-filled fuel cells were sort of popping. They go bump, and then that's it. So in other words, it wouldn't even be necessarily all that great a flame.
Not that glorious. Okay.
Unless
fine.
we
No.
did the whole... Listen, you're talking on a scale of humans.
Sure, if you could put all the planet in a box and pump that box of oxygen, it would probably look cool. It would actually might blow the box apart, and then you're back into vacuum and you're back in square one. But you've removed some of the atmosphere.
And gotten a big explosion. We wouldn't need the box either, though, right? Because we have an atmosphere. We could just pump the oxygen into it, and the gravity of the planet would keep it there.
Okay, yeah. So you mean
Oh.
where do we get the oxygen from? Yeah. Okay. Step one, get oxygen. But once we have it, yes, you could pump it. Well, here's the thing, though. I don't know what would happen. Would it just hang around as free O2, ready to help burn things, or would it bond with all the stuff that's there? Because the hydrogen and the oxygen might bond, and you might get a lot of water, which is the exact opposite of what you want.
Yeah,
if you want
that's
to burn
not
stuff.
what we want. But that's
No.
a good
Right.
point. I wonder, how quickly do those kinds of bonds form? Could we
Pretty
outrun it?
fast. I mean, with enough self-belief, probably. But I'm not really
And
sure
in
we could.
spades.
So lighting it on fire is probably a no.
Might not be the best way. But if we're still really interested in just removing the outer layers to get to those diamonds, then we have other options. And one of the best ways is we can use, we've got two big options. One is we can use gravity. So we could use something that's much more massive than Uranus, put it nearby. Again, step one, find something with crazy high gravity. Step three, solution. So I'm not quite sure about step two yet. And its massive gravity would pull the atmosphere of Uranus off.
Wait, what?
Right? Like maybe like a white dwarf or something.
Right, so you have to find some way to secure Uranus.
Yeah, right? Or just somehow put in thing in there, Uranus will start to orbit, whatever this thing is, and it'll just strip the outer layers of Uranus away, right? Now that could be kind of difficult, because I don't know where we're going to get a white dwarf. Right? Something small, massive, that we have to be able to move.
I mean, here at Dead Planets, we have magical powers, so we can just put one near it.
Yeah, last season we had a black hole machine.
Okay, take the black hole machine and make a small black hole. At some distance, we can figure it out later, and it will just suck the atmosphere off.
But it would have
Right.
to be the right distance such that it would pull the atmosphere, but not the entire planet, right?
Yeah, but that's what maths are for, right?
Okay,
Mathematics. We figure we'll do that in post. All right. Okay, so we assume we've got a thing, and it'll suck the atmosphere away. Okay, great. I mean, there's the whole other issue of like you disturb the orbit of the planets, and then people will be weepy and gnashing of teeth because the solar system goes unstable. But like that's a minor issue. Okay.
That kind of
So-
always happens to us.
We can fix it with all the diamonds, probably.
Yeah, the diamonds will. Everyone gets a block of diamonds to make them feel better for the fact that like Earth is now synchronously rotating around the sun, and one half is boiling.
Great.
But they've got cool diamonds, so. So just keep quiet about it. Okay, so
the
if you can
diamonds have trickled down.
the diamonds it's trickle down diamondonomics. Now, if you have so you vacuumed away the outer bits of Uranus, that's one way of doing it. But that might take a while. I don't know. It wouldn't be as cool as what my next suggestion is.
Now we have a special offer for Dead Planet Society listeners. You can get a 10-week digital subscription for $10 or £10, which includes unlimited access to our website and app. To learn more, go to newscientist.com/DPS offer.
And if you enjoy our podcast, you might also enjoy my free monthly space newsletter at New Scientist, Launchpad. Check it out at newscientist.com/launchpad. And if you love eclipses, New Scientist Discovery Tours now has 2 new eclipse tours live on our website. One going to Greenland in 2026 and another sailing the Nile in 2027. Go to newscientist.com/tours to find out more.
Let's slam something into Uranus really hard and fast.
Yeah, okay,
Yep.
let's do it.
All right. Because because there is a thing called impact blow off, and the idea holds that and we think this is probably a really important factor early on in solar system history when all those planetesimals are accreting and crashing into each other, and you make maybe a world not quite as big as Earth, but it's still a world, and it's got a temporary atmosphere, and then another thing whacks it, and the kinetic energy of that impact is so much that it literally blows away a good chunk of that air into space.
Okay, this is
You know what I'm
incredible.
thinking?
What?
What do
You
you
know what
think?
I'm thinking? We're using Mercury.
I was thinking Pluto, but sure.
I was gonna suggest why don't we just like use all of them? But see, here's the thing: Mars is closer and less interesting than Mercury, because if we want to use Mercury, they have the same mass, but we're gonna have to go and pull it all the way out of the deep well and gravity well near the sun. All right,
Yeah.
I've other ideas for Mercury. So what we could do is we take Mars. Would Mars be big enough? No, we probably want Venus as well.
Both of them?
But why not?
Yeah, okay.
You've got
I'm
powers, right?
picturing like the two of them somehow tethered together and we can like
Why don't we
whip them
just use
around.
Yeah.
Neptune?
Well, I thought we were going to keep one, like 2 kidneys, right? We're going to keep one for
Yeah,
spare.
but if we're getting rid of Mars and Venus.
Listen, there's a lot of planets out there. We'll replace them, okay?
Okay.
You know how many
fine.
planets? There's like thousands of planets. They're not
Okay.
rare.
We got it.
Admittedly, they're in other planetary systems, but again, that system minor, your black hole machine probably help us there somehow.
Okay, so Mars and Venus, yeeting them at Uranus.
Yes. And we want to yeet them fast enough that they're going to blow off a lot of that outer layer.
Is it like a
Right.
1-2 punch or hit at the same time?
I don't know. I don't know. We'd have to, I guess where the maths would come in again. Because maybe it's better, because there's other things too, right? Like you don't want to hit it straight on because you don't want to risk completely obliterating the thing because it's going to get harder to get the diamonds. But you want to get that outer layer off, so maybe you come in at an angle. But the thing is that, yeah, exactly. But the thing that governs that is it's going to be a function of 2 main things. There's the mass of the object, and Mars is a lot less massive, at 1/10 the mass of Venus. But the velocity matters too. So under the assumption that we can, even your black hole machine we could use to accelerate these things. We could do a gravity assist, put the black hole somewhere, I don't know, where out in space, and then basically get these things to go high and speed up.
Get a little kick.
Yeah, exactly. Or a big kick, and we make these things go really fast and slam them into Uranus.
But then I worry that the slamming into would set it off on a trajectory where it would leave the solar system and the diamonds are gone and we don't even get to find out what's inside of it. And then we've
Okay,
just
okay,
lost
all right.
it.
Okay, so 2 things. One is you're not going to make some omelets without breaking some eggs or diamond, right? 2, Neptune is our backup if we screw it up. But I think we could design it such that, so for example, if
we can have them coming in from each side.
Oh,
yeah, or they both come in the opposite direction the way Uranus is going around the sun so that we maximize the impact velocity. That's also because what's going to make Uranus go away is if we accelerate it so much that it's able to go beyond what we call a heliocentric orbit. So if we're not accelerating it, if we're slowing it.
But this reminds me of when your kids are fighting and they're like, I didn't hit you, you just ran into my hand. It's sort of like, we just put
Mars,
a couple planets in your orbit.
Yeah, on a direct collision trajectory, very much on purpose. And Uranus has happened to slam into this thing at some closing velocity of many tens of kilometers per second. Now, here's the thing too. If we are clever about it, which we won't be, we might be able to slow Uranus enough that its orbit will actually get smaller, and then it'll be easier for us to get them diamonds.
Oh, I like this.
Right? We're bringing it in closer. Now, maybe
we started out with a very scientific goal, and now it's just
a diamond heist.
Let me at them diamonds.
This is science. All right, we're reducing trip times, which reduces the cost to retrieve these diamonds. We're hopefully stripping off most of that outer layer.
Which is, even without burning it, we kind of already know what that outer layer is made of, right?
Yeah.
So then we can look at the layers that are closer to the middle and learn what they're
here's
made of.
Here's the interesting thing, right? So all of that weird supionic water ammonia slushy mix that might be down there, that stuff is under crazy pressure. If we've stripped off the upper some amount of that atmosphere, suddenly that stuff is now under less pressure, so it's going to puff up a bit, and then we hit it again, and we remove more. And eventually the goal will be to boil off that ocean and get to those diamonds. And you know what? Maybe Mars and Venus isn't enough, in which case we go back for Mercury.
It's like one of those big jawbreakers. You get rid of the outermost layer, and the next layer is like a different color and a different flavor. And then you get rid of that one.
And it's under less pressure, so it'll kind of like sort of expand a little bit, right? We're taking up these layers. Yeah, I guess it's a little bit like shooting a gobstopper with a really with a, I don't know, pellet gun or a pistol or something, or kind of like chipping off out of layer. But it's not solid, right? It's
But then,
kind of like,
yeah, that's what I was going to say. Then once you have chipped that off, you've got, instead of a jawbreaker, some cotton candy or something. Like, I don't know how puffed up it gets.
so it's going to kind of puff up and the liquid will turn to vapor. It'll still be gravitationally bound, so the atmosphere will still be there, but it won't be as thick, it won't be as deep. And so there'll be other different changes in chemistry, and then you hit it again. You keep doing that. Maybe you got to get some exoplanets here. I don't know. Maybe we want to use the moon. I don't know what it's good for otherwise. So
We can get rid of the moon.
keep
That's
that in
fine.
too.
Yeah.
But I don't know what I haven't done any calculations to figure out like how fast we have to go to have the impact we want. Haha. But the point is that eventually, maybe Venus would be enough to do it itself. Either way, you've taken off this thing, and then you've exposed those diamonds.
And the layer that the diamonds may indeed be in, if we have that right, you said it's going
Can
to
you
sort
imagine if we don't? It's like the Heist movie where they split open the vault and it's empty. It's just a bunch of dollar notes. You're like, this sucks.
Yeah, that wouldn't be the greatest. But if that whatever nugget is inside Uranus starts sort of being exposed to space and sublimating and puffing up, does that mean it would have a kind of tail? Like, could we see it from here trailing this vapor?
Yeah, probably it would, because it would remain gravitationally largely bound to the sun, so it probably would be a tail. It'd be a big vapor tail coming off. I mean, Mercury has a tail, right? If you've got a telescope that can see sodium, so Mercury has what's called an exosphere, and an exosphere is a kind of atmosphere that's a piece of shit. And basically, the idea of the exosphere is that it's
Hold on.
Yeah, that's what an exosphere is. I mean, there are people who study these things. They find them really interesting, but they're kind of cool because they're made of the stuff the ground is made of. And in the case of Mercury, its exosphere has three main species: sodium, potassium, and calcium. And the idea is that they are major rock-forming elements. And what's happening is you have all these micrometeorites that are just hitting this thing the whole time, and basically sputtering is the word we use to kind of imagine hitting the ground and kind of reworking it on, almost, atomic scales, and knocking chunks of atoms off mineral crystals.
It's like it's being sandblasted.
Essentially, that's what it's been, right? And some of that stuff will be lost to space, but a lot of it is heavy enough that Mercury's gravity will hold on to it. And they may eventually come back down again, right? Because an atom is still a small physical object that is capable of behaving ballistically. But a lot of this stuff will stay gravitationally bound, but not on the ground. And so that's forming this exosphere. And it just happens that because this stuff is being sputtered off by impacts hitting the surface of Mercury, there is a tail.
But so here's the thing. So Uranus could have a tail like Mercury does as well.
If we're punching its atmosphere away with strikes, yes.
I'm also wondering, like, would we, if I viewed this collision from Earth, would I be able to see the atmosphere being blown off in the moment?
Yeah, probably, yeah. You'd see a white flash, and then you'd see sort of a kind of a diffuse cloud. But that wouldn't be a good vantage point, because it's really far away.
No, I mean, I want to be right next to it.
Yeah, we want to be out there kind of close enough, but also like an uprange.
Yeah.
Because it's going to look cool. Because it's going to go in, right? It's going to go in real fast. It's going to go in, like they'll close at the speed they'll be traveling. They'll be visibly closing on each other. But it'll still look slow-mo. And then one will go in, and then there'll be this kind of, because when we simulate this in computers, you get really weird effects, and the entire body will start to warp, but there'll be a bright white flash. It won't look like the pictures you see on Google, like, because I've never seen, I think that in my opinion comes close to what it actually looks like. It won't be like a kind of a ring shock wave and a big splash. It'll all turn to incandescent vapor, so it'll actually be kind of hard to see the details because it'll just be this big glowing vapor cloud.
Like a fog.
But you can tell, yeah. But what the lizard part of our brain will recognize it for what it is. Like there's something unholy happening. And so, but then what will happen, you'll get this sort of big kind of vapor thing that will push away, and there'll be this kind of big ejector curtain, and that stuff then is the vaporized bits that we want to remove. They'll probably cool off and condense again, and I think we can reasonably expect they'll form this big kind of cloud, and they may form that tail as the whole system is continuing on its orbit around the sun.
But when you say condense, would they condense down into a small little body?
No, I think they probably just cool down into vapor, but the vapor would be gravitationally, the hope is it's gravitationally unbound to Uranus, so now it's just trailing around the sun. It'll just dissipate away eventually. but I can assure you it would look really cool.
Especially if we did a whole bunch. We have a bunch of little creepy clouds.
Yeah, it would. Yeah, little puffs. Each of them corresponding to when we just slammed about 1/10 of the mass of the planet off in one go.
Well, we failed very quickly in our original pursuit of spectroscopy.
But we did potentially end up with a cosmic light show and a bunch of diamonds, so I feel like we came
that
out
seems
ahead.
better.
But also, to be fair, like we already spectroscopically have data for Uranus, and we don't need to set it on fire to be able. Like we can learn by just looking at emitted light. I don't really know
That's
if we
no
were
fun,
looking to do
Paul.
spectroscopy. I think our original idea was to burn the planet.
It
And we
was,
failed
yeah.
in that regard. That's true. That's
Yeah.
true.
That's all for this episode of Dead Planet Society. Thank you so much for listening.
If you want to catch up on previous episodes, head over to newscientist.com/deadplanets. Look forward to new episodes every other Tuesday, right here in the New Scientist feed.
And if you've got a cosmic object you'd like us to figure out how to destroy, let us know and it could be featured in a later episode of the podcast. Our email is deadplanets@newscientist.com.
Bye.
Bye.
There's a lot of things you could do. You could have all of your teeth bedazzled, right? You
Oh,
could
yeah.
definitely with Uranus diamonds. You know, that's a wisdom that my mom passed down to me. That's what she used to say too. Especially if you dig that diamond out of the core of a gas giant.